Chapter 4.2, Day 1, Pascal's Triangle. Right now you're going to pay attention on this figure and see the pattern in it. So you start with 1 and then this 1 goes to the two sides. One is at the front and other one is at the back. So this one, these are the two blocks. One block goes in the front and then the other block goes in the back. In between, you're going to get the addition of these two numbers. That's going to be 1 plus 1, that is 2. In the next step, the block, this one, goes in the front and this block goes in the back. In between, you're going to get the addition of these two. So 1 plus 2, 3, and 2 plus 1, 3. In the next step, after this step, this one goes in the front, this block goes in the back. In between, these number will be the addition of 1 plus 3, that is 4, 3 plus 3, 6, 3 plus 1, 4. So this is how the block and the pattern is going and is going to go forever. And this pattern is called Pascal's triangle. And this one is useful to write down any binomial power into a standard form. So if the a plus b to the power 2, then we're going to use this pattern. If there is 3, then we're going to use this pattern. If 4, then we're going to use this pattern. See how this works. It's also important to read this definition. It also helps you understand the pattern more. So in a Pascal triangle, the first and last number in each row will be always 1. So 1, 1, 1, 1. And every number other than 1 is the sum of the closest two number, the row directly above it. So 1 plus 1, 3, 4, 3 plus 3, 6, 3 plus 1, 4. The numbers in Pascal's triangle are the same numbers that are the coefficient of binomial expansion, as shown in the first 6 rows. So we are going to expand this binomial expansion with different powers. So the binomial expansion will follow this pattern. We're going to start this row by 0, so where n is going to be 0. A plus b to the power 0. Anything to the power 0 is always 1, so the answer is 1. So the Pascal triangle that starts from 1 is this section right here. So in the next section, the row is 1, so n is equal to 1. A plus b to the power 1. Now you're going to have this one is 1a plus 1b, because this is just a plus b. Rather than just writing a plus b, we are going to write 1a plus 1b, and you can see that this is the this first row right here. And in the Pascal triangle, we just write is 1 and 1. The next one, we are going to use the row 2, where the n is 2. A plus b to the power of 2. Now we are going to use this row where you have 1, start with the 1a square. In between you have 2, so you're going to find out that this is a coefficient 2. Multiplication of these two numbers, a and b, plus the last coefficient is 1, so it's going to be 1b squared. And Pascal triangle third step is going to be 1, 2, 1. So the coefficients are 1, 2, 1, 1, 2, 1 here. Next row you're going to use is for 3, and that's going to be a plus b to the power of 3. So for the third step, you're going to get a plus b to the power 3. You're going to get 1a cubed. Other coefficient is 3a square b, 3ab square plus 1b cube. And then the step number 4 in this Pascal triangle is 1, 3, 3, 1. 1, 3, 3, 1. So by the fourth step, which is when the power is 3, you can see the pattern that always the first number starts with the a and the highest degree, that is 3. And then once you start with the highest degree a to the power 3, after that a starts to go down in power. So we start with a3, and then it's going to be a square, then a, and then no a. Similarly, for b, it starts with no b, then it starts to increase its exponent. So no b here, then b, 1 power, b square, and at the end you're going to have a b cube. If you notice, the same pattern is going to follow in all of these binomial expansions. This one start with the 1, 2, 1, so the coefficients are 1, 2, 1, but for the degree it start with the highest degree for a, and then they start to go down, so a square, and then a, and then no a, or a to the power 0. For b, no b means b to the power 0, then b, and then it's increase it to the highest power, that is b square. We're going to follow the same pattern when we use row 4 and then n, which is the power 4, and you're going to use these numbers right here. So when you choose the power 4, then it's going to be a plus b to the power 4, and then the coefficient we already know that is going to be 1, 4, 6, 4, and 1. So that are our coefficient: 1, 4, 6, 4, and 1. So it start with the 1, a to the power going to be the highest degree 4. There is no b or b to the power 0, which is 1 anyway. So then you're going to have the next coefficient, that is 4. A starts to go down, so it start with the power 4, so this one is power 3, and b to the power 1. Now 6a square, b to the power square. So see that a is going down. So now in the next one, a just 1 power, b is increasing to 3rd power, and on the last one, b is highest power, that is power 4, and there is no a or a to the power 0. For the last row, I chose n as 5, so a plus b to the power of 5. Now I'm going to use the same pattern. I do not have a next row, but we can still make it over here. So let's see how we're going to make it. So next row is going to be the 1 goes on the side. In between you have 1 plus 4, that's 5. 6 plus 4, that's 10. 6 plus 4, 10. 4 plus 1, 5, and then 1. These are the coefficients of the binomial expansion. Start with the 1, and a to the power, highest power is 5. Now the next coefficient is going to be 5, so 5. A to the power is going to be 4, and b is to the power 1. Next coefficient is 10, a to the power 3, b to the power 2, and next term is going to be 10a square, b to the power 3, 5a b to the power 4, and 1b to the power 5. Again, if you notice, a start with the highest degree and keep on reducing by 1, a to the power 5, a square, a to the power 4, a to the power 3, a to the power 2, a to the power 1, and no a. Whereas on the other hand, b start with the lowest degree, which is 0. So no b, b, then b square, b to the power 3, b to the power 4, and at the end you're going to have the highest power for b, 1b to the power 5. So for letter A, the power is 5. It means we are going to expand it like this. all we have to figure out is what is A and what is B. So if I compare this with the factor of x minus 2, then A is x, and then B we can consider as negative 2. So all I have to do is that I'm going to plug it in A as x and B as negative 2 in this expansion. So what I'm going to get here is x to the power 5 plus 5 x to the power 4 and negative 2, 10 times x to the power 3 negative 2 to the power 2 plus 10 times x to the power 2 negative 2 to the power 3 plus 5 times x times negative 2 to the power 4, and on the last one negative 2 to the power 5. When we're going to expand this, you're going to get here is negative 10. So it's going to be negative 10x to the power 4. This is going to be 10 times 4, so that's going to be 40 x to the power 3. So this is going to be negative 8 times 10. That's going to give you negative 80x squared plus 2 to the power 4 is 16, and then 16 times 5 is 80. So 16 times 5 is 80x minus 32, because negative 2 to the power 5 is 32. So that's your expansion and your answer for x minus 2 to the power 5 using Pascal triangle binomial expansion. Next is letter B, where you're going to solve for x 3y plus 1 to the power 3. Pascal triangle expansion is 1a cube plus 3a square b plus 3ab square plus 1b cube, where your a is going to be 3y and b is 1. So all you have to do is plug the 3y for a and 1 for b. So your answer is going to be 3y cubed plus 3 times 3y square times 1 plus 3 times 3y 1 square plus 1 cube, and that's going to be 27y cubed plus 9 times 3 27y square plus 9y plus 1.